going to try the last question from 2007, but I want to point out a few things to you as we start looking at this question. And one of the things I wanted to point out, remember this document that I shared with you where I've got links to all the various questions. And I mentioned how I was going to highlight the numbers that I thought were most relevant to our modified exam. Number 4 is not highlighted, and it's not highlighted for a few reasons. One is this problem deals heavily with interfaces, which are purely abstract classes. Those have been removed from all AP CSA tests going forward as of 2020. So not even the fact that our test this year is modified, just that wasn't going to be a part of our exam anyway. And then in addition to that, we have to write an entire class. That won't be on your 2020 test. I guess the one sort of positive thing in this question is the use of methods and control structures. So if we are going to take anything out of this question, that's what it is. Calling all of these local methods, satisfying the parameters, understanding the return types. Where can we call these? Who can we call them on? But we won't see any interfaces on our exam, and we won't have to write a complete class either. So anyway, keeping that in mind as we look at this question, there's a lot going on here. So we've got to run this game. They give us an interface called GameState. An interface is just like a menu of options. So if you have a game state, these are all the things you can do to it. You can ask if the game is over, okay? You can ask, who the winner is. He'll come back to you as a player. We're going to learn more about that. You can get the current player. You can get a list of strings of the current moves. You can make a move. You have to have the string move to do that. And then there's a toString, which prints or returns as a string the current game state. We're actually going to need that coming up. So they mention here like tic-tac-toe, but this is really left in a pure abstract nature, and they say it could represent any game. And so when I made a tester case for you here in the Replit, that was kind of a challenge. My tester is very boring, and it's if you wanted to try to write something more interesting, you could. Maybe if you do, share it with me, and I'll share it with everyone else. But I left it pretty simple. So anyway, in part A, we've got this player class. We're going to extend it to a random player, and a random player basically just selects a random move. So remember that if you have a game state, you can get an array list of the current moves, right? If I have a game state, I can get an array list of the current moves. A random player would then look to randomly select one of those moves and return it as a string. If there weren't any valid moves, then the size of this list would be 0, and they give me a special case. So if that were to happen, I should say no move. Okay. I've gone ahead and written the code out for you here. So just if we look at some of the highlights, notice that I said extends player. Okay, so that makes it a subclass of player. The one thing that we struggled with a little bit there is, if a random player wants to be a player, okay, then it has to be built around a string name. Okay, a player is demanding a string. So any subclass of player, job 1 in the constructor will have to send a string up to the superclass. That has to be the first line of this constructor. Okay, so that's mandatory. The directions told us specifically to override this method. So I kept the exact same signature. It's going to return string, it's public, and it's receiving a game state. That's kind of weird. It's an interface. We didn't learn about interfaces. The bottom line is if you give me a game state, I can do any of these things to it, like we were just mentioning, this menu of methods. These are the things we can do to a game state. So the one that I want is I want to get the current moves associated with this particular game state. So with this game state, give me all the current moves. It will do that, and it will give them to me as an array list of strings. If there aren't any moves in there, I'm supposed to say no move, okay? And this is a string return type, so I returned it as a string literal. If there are moves in there, I want to randomly select one. So first I generated an index that represents any of the valid indexes associated with that array list by using its size and map.random. And then I just returned any particular one of them with the get method. Okay, so that handled part A. Part B is, again, pretty abstract. We're supposed to write the play method, and they lay it out for us here as a sequence of events we're supposed to go through. So what do we do? Well, this method should first print the initial state of the game. If you remember in the GameState interface, it mentioned that there was a toString method that would do that. So we can just implicitly call that method by saying system out print line, whatever the name of our GameState is. Then we should repeatedly go through this set of steps, determine the current player, get that player's next move, print both the player's name and the chosen move, and make the move. Okay, so like 4 statements there that we'll have to write. Now we do this until the game is over. Now that's interesting that that's the next sentence, because then that kind of comes back to that word repeatedly, and that lets me know how I'm going to repeat this process. I'm going to write a while loop simply saying while, not is game over. Now, is game over, where did I get that from? Well, is game over is a method that I saw inside of GameState, okay, the interface. When I'm writing code in part B, this class has a GameState called state. So what I'll do right here is I'll say state.isGameOver. And for the game state that belongs to this class, the one that brings me here, this instance field, okay? I shouldn't say the one that brings me here. The one that belongs to this class has an instance field called state. I'm going to ask if that game is over. And really, I want to know if it's not over. If it's not over, I keep going through this menu of steps, this 4-step process. When it is over, I have to print out who the winner is, or print that the game ended in a draw. And there's some hints for how we'll do that here in a minute. Okay, so looking at my part B solution, you might remember the very first thing they wanted us to do is just print the state. So this is the state of the game. You could say state.toString. Just recall that that's optional, right? That's implicitly done for me if I don't do that here explicitly. Here's that while loop I mentioned. Okay, as long as I don't have a winner, there's a 4-step process I want to go through. One of the things was to get the current player. Get current player is a method found in GameState. So I can only call that method if I have a game state. I have a game state, it's called state. Okay. I then want to get that player's move. Now, get next move is not a game state method. That is a player method. Okay. Get next move is a player method. So I called that on the player reference that I created in that first line of code. That method requires as a parameter, an argument, a game state reference. So again, I had to use that reference state. This method gives me back a string representation of that move. Okay, step 3 of this while loop was to print the player and their move. Okay, so to print the player, I noticed in the player class there was a getName method that would take the player's name as a string, and I concatenated that with their move, which already was a string. So I didn't need to do anything to that. I didn't notice in the directions of the player class a toString method. Okay, unlike GameState, I didn't notice a toString method here, so that's why I went to the getName method. If not, maybe printing player would result in like a memory address or something, and I didn't want to risk that, so I went ahead and extracted their name. And then finally, I had to make their move. Okay, so I noticed in the GameState class or interface again, there was a make move method, and that method can be called on any GameState object reference. We have one called state, as long as you give it a string representation of the move, and I did that there, M, that I determined earlier. So that's that 4-step process that we see back here in part B's directions, my 4 blue underlines. Get the current player, get their move, print the name and the move, make the move. I keep doing that as long as that method is game over, keeps coming back false. Once it says true, I break out of the loop. Okay. The only way I'm ever going to possibly reach this line of code is if the game is over and the loop is broken. Okay. At that point, another GameState method is getWinner. It returns the player reference as to who won. But there was a little note in there that said if there was no winner, it would come back null. So if you look at getWinner, okay, null if there is no winner. So null if there is no winner. So if I saw null, I knew that the game ended in a draw. That was what they wanted me to print. And if there wasn't a draw, if there was a winner, I got their name and I said that they won. My tester class is pretty boring, so I only put one player in. I think if move 2 is the last move, it says draw. And it is random, so you might want to run it a few times. And I think I set it up so that when move 2's last, it says draw, but otherwise, Randy wins every single time. So, like I said, it's pretty boring. If you want to make a better tester class for me, you could make tic-tac-toe or coin flips or something. I don't know, whatever you want to come up with, and share it with me. That would be great. I'll share it with everyone else. But yeah, right now there's not a lot going on in there. You can look at it on your own a little bit if you want to. Again, we're not going to have interfaces on our test, okay? We're not going to have abstract. We do have to know how to call methods, though, and coordinate our objects and our classes together. So there are a few good things here. But at the same time, if you're just blown away by this problem, don't stress out over too much. There's a lot going on here that we never really learned explicitly in our course. So don't be too worried about it.